So the next chapter is dynamics. We have discussed about kinematics and dynamics in the previous lesson as well. That when it comes to motion, we divide it into two parts, kinematics and dynamics. And what was the difference between kinematics and dynamics, Shirino?
Kinematics is a study of motion without considering its causes, and dynamics is a study of the result of force.
Yes. We discussed the cause of motion in dynamics, and we we do not discuss the cause of motion. So in this chapter, we're going to study about force first. How do we define force? The very basic definition that the students memorize is push or pull on an object. What force can do, it can change direction, it can change motion, it can change the state of the body, and so forth and so on. There are four things that a force can do, and it was right here. I'm circling it out for you. Force is a quantity which change or tends to change the state of body, start or stop its motion, speed up or slow down, and can change the direction of motion. These are the four things that a force can do. And there comes to mind that can it change the mass of the object? So no, it cannot change the mass of the. So it can change the state of the body, start or stop the motion, speed up or slow down the body, and can change the direction of motion. And force is defined as it's a vector quantity, and it is defined as the push or pull on an object. It is a definition of dynamics as well. We will study the connection between force and motion, which is the subject called dynamics. Okay? If I take you to the other book, they have given the same definition just for you guys to understand. The branch of mechanics that deals mechanics हमने पढ़ा था ना, study of motion, cause and dynamics. ठीक है. Here is the definition of the motion. Force. A force moves or tends to move, stops or tends to stop the motion. The force can also change the direction of the. These are basically the properties of the forces. But when it comes to definition of the force, that I have written it for you. The push or pull on an object is known as force. There are different types of forces that we're going to encounter in different chapters, but the we could say the major forces that we're going to discuss are weight. I'll go through the definition there. Weight, upthrust, tension, drag force. There are many other types of forces as well, but we're going to discuss step by step movement. Okay. Now, how do we define weight? Formula क्या है उसका? W is equals to mg. Upthrust, tension, drag force, and movements. We do not discuss. We discuss the formula for movement, which is equals to F cross T. Here T is known as the moment arm, which we're going to discuss in the later chapter. So do not worry about that. It's just we need to be familiarized with the types of forces. Okay? If something is called a force, उसके units हमारे पास क्या होंगे? Newtons. ठीक हो गया? Upthrust is defined as the force which acts in the opposite direction of weight. In a biwater. और weight को define करते हैं the force with which the earth attracts the body towards its side. Force or weight always acts in the opposite direction. In the downward direction. Whatever, sorry, whatever the weight of the object is, it would always act at the center of that object, and it will always act in the downward direction, and its value would be. And the value that acts in the opposite direction of force is upthrust in water. Okay? If the similar object is placed on a table, which force would be acting downward? Amna, which force would be acting downward?
Wait.
Yes, and in the opposite direction of it would be contact force.
Okay.
Or we can also call it normal force. At times it's called normal force as well. It has certain deeper meanings as well, but for our course, we do not need to get into detail with that. So are we clear about force, its definition, its different types? We have discussed weight and upthrust. It is and tension. Now we're going to go to tension. How do we define tension? Anything that comes to your mind regarding tension? Have, have you heard this term before?
Yes.
Can you elaborate on that? Tension is mostly defined as the force that acts in the opposite direction of applied force by a medium such as rope or cable. If there's some sort of string or rope or anything that has the property of a string or anything like that, so in the opposite direction, suppose I have just a simple pendulum we have discussed in the previous chapter. Have we discussed simple pendulum? No. Okay. If I've hanged something with the help of a string, this is a mass. Okay. So its weight would be acting in the downward direction as usual, and in the opposite direction of weight, there would be a force known as tension. If the object is stationary, both weight and tension would be equal in terms of magnitude. If there is any kind of motion, then we'll discuss that in detail in the next class, maybe. Okay, so जैसे upthrust था ना, upthrust is a force that acts in the opposite direction of weight in water. Similarly, tension is the force that acts in the opposite direction of mass when it is attached to a string. ठीक है? Am I clear about tension? Can I go to the next one?
Yes.
Yes.
Drag force is the resistive force. It is the resistive force that acts in the opposite direction of applied force in fluids. Whenever an object is moving across the fluids, it could be air, it could be water. तो हमारे मोशन के ऑपोजिट डायरेक्शन में जो फोर्स लग रहा होगा उसको क्या नाम दिया जाएगा? ड्रैग फोर्स. Suppose I'm out of space now. Let me draw it here. Suppose I'm going, this is object, this is water. Okay. And in which direction the weight would be acting? Weight again would be in the downward direction. Upward direction में क्या होगा? Upthrust. This is the motion or applied force. And in the opposite direction of motion is the drag force. It is a resistive force which would tend to stop the object. Whenever there is motion, there would be some resistance offered by the medium in which that object is moved. Clear?
Yes.
Let's see what book has said so far. The very first force that they have discussed is a contact force. Force acting between two objects that are in physical contact are termed as contact force. I have given you the diagram as well here. This diagram. Okay. Whenever two objects are in contact with each other, the force, for example, when ball touches the bat, there would be a contact force. Okay. A force perpendicular to contact force that keeps object passing through each other is called a normal force. A force perpendicular to contact surface that keep objects from passing through each other is called normal force. वो तो मैंने आपको ऊपर टेबल का कहा था ना, I've written कि normal and contact force दोनों we can call it. तो perpendicular to the surface लग रही है ना force. Perpendicular, do you know the meaning of perpendicular बेटे? 90 degrees के
Yes.
ऊपर. If anything is acting at 90 degrees to it. So the normal force would be called, a force would be called a normal force. Contact force, normal force कब बनेगी? When it is acting perpendicular to the surface. Okay. And here is the thrust. The force that propels a flying machine in the direction of motion is termed as upthrust. For example, engine produces thrust. The thrust in the car causes it to accelerate as shown in figure 33.3. Here is the example of normal force. Here is the example of thrust that acts in the direction of motion, and drag force is की opposite direction में लगेगा. Here is the example of tension. Tension that acts in the opposite direction of weight, and friction is always resistive force is known as friction. Drag force is an example of friction. Then force that resists the relative motion of solid surface, fluid layers, and materials and element contact and sliding against each other is called friction. एक second hold करो. Then the resistive forces that acts in the opposite direction of motion is known as friction. And यहाँ पे से further to explain किया, friction of an object acts in the direction opposite to the direction of object's motion. Here, air resistance is also called frictional force which occurs between air and object, जिसको हमने drag force भी कहा. ये देखो से लिखा भी हुआ है. It is called a drag force which resists the motion of the body with the fluids. We have, and here's a definition of tension. The force exerted by two or more physical objects that are in contact through string, rope, cable, or spring. We call such a force as tension. Then the forces are divided into further two parts. They are known as contact force and non-contact force. Contact force क्या होगा हमारे पास? For forces to act, both the objects must be in contact with each other. Then it would be known as a contact force. If the force that acts on two objects without being in contact with each other, they are known as non-contact forces. As the vocabulary is telling you the meaning of it, contact and non-contact force. Okay. But the only thing that you need to keep in your mind is the examples of contact and non-contact forces. They have only discussed about the non-contact forces. So let's just contact इसके opposite ही होगा, ठीक है? Here's the definition. The force that acts as a distance without any physical context between bodies is termed as non-contact force. This force acts even if the object involved are not touching, also termed as the action at a distance force. Examples are gravitational force and electrostatic force. उनकी definitions भी respectively साथ साथ ही. The attractive force between two objects with mass is called gravitational force, and an attractive force or repulsive force experienced by a charged particle is known as electrostatic force. आगे उसने उसकी examples भी देंगे. For example, attractive force between a positive charge and a negatively charged nucleus is a non-contact force. And magnetic force is also an example of non-contact force. And attractive force. Out of the examples that we have discussed, which would you term as the contact force? Non-contact की तो examples हमने discuss कर ली. Of the definition that we have discussed above, which would you name as a contact force? I'm asking you guys. Hello.
Yeah.
Out of the forces that we have discussed above, which force would you name as a contact force? Is tension a contact force?
Yeah.
Yes.
What about normal force?
Yes.
Yes.
So that's what I was asking about. Then the forces, we discussed this normally, the students study them in the first year, second year, but they have given this topic in your course as well, the basic forces of nature. The basic forces nature of everything that is around us and have some kind of force in between present, they are known as the basic forces. And we have four basic forces of nature: weak nuclear force, strong nuclear force, electromagnetic force, and gravitational force. These are the four forces that exist around us and compensate for all the types of forces that are present here. देखो ये उन्होंने यहाँ पे लिखा गया. There are many different types of forces, but physicists have classified forces into four categories and based on how objects interact with one another. The four fundamental forces of nature are gravitational, electromagnetic, strong nuclear force, and weak nuclear force. Normally, the strong and nuclear forces, as the term you could see here, the nuclear term, these forces normally we discuss in respect to the nucleus of an atom. The forces between the neutrons and protons and the nucleus and the electrons that we're going to study in the later stage. Here you could see a strong nuclear force is the strongest of all the fundamental forces. It keeps normally pehle. Have you heard the name of Dr. Abdul Salam? Why don't you guys answers immediately? What is the weight about? Dr. Abdul Salam was the scientist, Pakistani scientist, जैसे Dr. Abdul Qadir Khan थे ना, जिन्होंने हमें atomic bomb दिया था. Similarly, Dr. Abdul Salam was a scientist who combined two basic forces of nature. पहले 5 basic forces of nature होती थी, electric force and magnetic force. But he combined these forces into one force which was known as electromagnetic force. And the scientists are working to combine electromagnetic force and gravitational force now. So that after that we'll be left with only 3 basic nature forces of nature. Okay. So the strong nuclear force is the strongest force of all. It keeps positively charged protons tightly packed in the nucleus of an atom by overcoming the repulsive forces between them. Protons are positively charged, and if the protons are existing in the nucleus, there must be some kind of a resistive force existing between the protons. But if they're still present in the nucleus and the nucleus is not breaking down, that is because of the strong nuclear force that is keeping the protons in the nucleus. A force between the protons and the nucleus, repulsive force of the protons and the nucleus is the strong nuclear force. Further on, they have explained that the exchange of strong forces are called pions, and the other heavy but strong nuclear force has a very short range, nearly equal to the diameter of a proton. That is, it only exists within the diameter of the nucleus. Are we clear about the strong nuclear force?
Yeah.
Yes, but what are pions?
Pions is the particles, exchange of particles strongly. It's a type of particles. That's not important in our syllabus. You just need to keep this in your mind. I told you that that is a topic that would normally students do in first year and second year, but they have given you these topics. Pions are. Do you know about the fundamental particles? Proton, electrons, and neutrons.
Yes.
ठीक है? For पहले, the early scientists used to believe that these are the fundamental particles, but later on they came to know that these are further made up of something which was known as quarks. And then वो फिर further उनकी categories में divide हों तो pions is one of the मतलब particle that exists in the nucleus due to the strong nuclear force. Quarks और anti-quarks से मिलके बनता है, but let's not get into detail of that. You guys won't understand that. But it is present in the nucleus. ठीक है? Short way में बताएं तो early scientists used to believe they are proton, electrons, and neutrons. Protons and neutrons exist in the nucleus, and electrons are revolving around it. And they thought that they cannot be further subdivided. Later on, it came to know from the modern physics and the quantum physics that they are basically made up of other particles which are known as quarks, mesons, and there are other so many terms, basic fundamental particles of nature. No? So pion is one of that.
Okay.
I would love to explain it to you, but I don't think at this stage you will be able to understand it. So let's just say it's a particle like proton and neutron. A weak nuclear force is very weak, 10,000 times weaker than the strong nuclear force, and has a short range of the fundamental. Despite this, a nuclear force plays a major role in the structure of the universe. It is an exchange force mediated by the exchange of three different particles called vector bosons. The weak nuclear force is responsible for radioactive decay. Specifically, the weak force changes the flavor of an elementary particle called quark. When this process occurs, a neutron in the nucleus transforms into a proton.
I made up of quarks.
Quarks are something from which the protons, neutrons, and electrons are made up of. ठीक है?
Okay.
अब flavor होता है. Flavor is defined as quarks. ना? There are 6 quarks from which the protons and neutrons are made up of. ठीक है? And flavors are basically the types of quarks. उनको flavors कहते हैं. They are top, up, down, जो है charm, and with respect उनके 6 हमारे पास वो होते हैं. So, with the help of weak nuclear force, we can change the flavor of quark. That हम up को down में change कर सकते हैं, down को up में change कर सकते हैं, charm को strange में change कर सकते हैं, strange को charm में. The flavors of the quarks. Let me write what quarks are. Basic building block of elementary particles like proton, neutrons, and electrons. They are made up of these. Okay. And quarks, there are 6 quarks from which these building blocks these are made up of proton and neutron. So with the help of weak nuclear force, we can change the flavor of the quarks. Flavor means the type, the 6 types that quarks have. Neutrons break down into a proton and a.
What are vector bosons?
Again, the fundamental particles. जैसे पायॉन्स था ना उसी तरीके से वेक्टर बोसॉन्स भी हैं. मैंने आपको बोला आप इजी माइंड में ये रखो जैसे हमारे पास इलेक्ट्रॉन प्रोटॉन्स एंड न्यूट्रॉन्स होते हैं, दे आर समथिंग फर्दर बिगर देन दैट. ठीक है?
Okay.
Did you get the meaning of fundamental particles, which are proton, neutrons? They were basically made up of quarks, and they are further categorized into so many other types: pions, vector bosons, mesons, and everything like this. These are the part. These belong to the family of the modern physics, in which we study that this particular thing is further divided into these particular things and stuff like that. They wouldn't ask any extensive question in regard to that, because that's very high level questions.
Okay, but like, I don't see the force. Like like it changes the type of elementary particle, right?
Yes,
So
yes.
I don't. Is it like I don't understand how is it a force?
It's just a, because we have studied that the force can change the state of motion. It could change. So basically, जो quarks होते हैं ना, they are spinning in a certain motions. उनके spin motions को we can change with the help of force, and they change into some other type. There are the spin motions which are related to these fundamental particles now. So with the help of force, we change that particular thing, or we break it into. उन्होंने बोला ना, weak nuclear force is basically the force that exists with the radioactive substances. You might have familiarized with the term of the element uranium.
Yeah.
So uranium is a radioactive element. It keeps on emit any radioactive elements. They emit radiations all the time naturally. So these kind of forces are exist. So we know that radiations, when we are exposed to radiation, it harms our body. In a way, it breaks down our cell. So basically, ये सारे को, if you put it into one picture, that's how these forces are responsible for all these things. You guys have heard that if we're exposed to radiations and now we got cancers, the ultraviolet rays coming from the sun would cause the cancer. How it's
Yeah.
causing the cancer? They're basically breaking down the cells in our DNA. So that these all are the types of forces. That's how the force acts. We're almost running out of the time. So can we go to electromagnetic force and gravitational force?
Yes.
Oh, electromagnetic force acts between electric charge. It includes both electric force and magnetic force. The electric magnetic force can exert either an attraction or repulsion. So on average, the forces tend to cancel out each other, and effect is not observed. Electromagnetic force is immediated by a massless object known as photons. अब photons we discuss कर दिए हैं. The massless nature of photons makes the effective range infinite, even though the strength of the force decreases rapidly as the distance between the object increases. The normal force, friction, and tension are caused by the direction of particles on the contact surface, and thus a result of the electromagnetic forces. Now you'll ask me what photons are. Photons are basically the packets of energies. They are defined as the packets of energy and are considered as the fundamental sources of quarks and everything that is around us. They came down to the basic nature and they called it photons. Photons को further categorize करते हैं, उसमें हमारे पास quarks and वो जो तमाम चीजें आती हैं ना, ये तीन basic चीजें हैं जिनकी basis के ऊपर we discuss the. So I'll explain you what photons are. Photons are basically packets of energies, and they are considered as the elementary. I will give you a review of these points again, and that would not be the part of lesson, obviously, because that's not something that we look that we need to work on at this level. So do not burden yourself with all these things, what photons are, what pions are, and stuff like that. Okay, just memorize them as they are the building blocks of nucleus. That's it. Nothing more than that. Can you guys do that without stressing yourself?
Yeah.
Just
okay.
think of them as the basic building blocks of you could say the nucleus and the matter.
Okay.
Acha. Moving on to the next thing is we have gravitational force. Gravitational force we're familiar with. This is the only force that is guys are familiar with. What is gravitational force? Gravitational force is only the is attractive force that exists between the due to their masses. Okay? And the scale of distance between them. Normally, we do not discuss the formulas of it, but gravitational force is dependent on the product of the masses between the two objects, mass of the two objects, and the distance between them. And the formula is given as, do not need to memorize this formula.
Sir, I cannot see the screen.
Oh, sorry. I think I forgot to share the screen. Can you guys see the screen now? Can you see it
Yeah,
now?
now I can. Yeah.
Yeah.
So the gravitational force or the force of gravity is the force of attraction. It is the attractive force, okay? It's not a repulsive force. Like in electromagnetic force, it's attractive and repulsive both. But gravitation force is only an attractive force. Gravity is by far the weakest of the four fundamental forces with the least strength. The force of gravity between two objects is noticed only if at least one of the object has a larger mass, such as normally, if you and Shrino are standing together, you would not. इसका meaning ये है कि these forces are normally not visible on the smaller masses. These are only visible when there is a major difference between the two masses. For example, if there's a person standing and there is a planet in front of it, the whole planet in front of it, there would be a massive mass difference between these two. Then we will observe the effect of gravity on us. Otherwise, if there's not much of a, have you the black hole, do you guys know what black holes are? Not know what black holes are, but have you guys heard about this term?
Yeah.
So black holes basically it is the massive source of gravitational force. So whenever it goes inside, it never comes back. It is because it has a strong source of gravity in it, and it is because of the mass. It's so condensed inside to the core that the gravity is so strong that whenever something is closer to it, nothing comes back out of it. So gravity is only visible if there is a major mass difference between the two objects. You guys get the point now? It is only noticed only if there's a major mass difference. It holds them together and controls their motion the same way that controls the motion of the falling object on Earth. Gravitational force is theorized to be an exchange force with massless mediating particles, gravitons. The massless nature of gravitons allows gravity to have infinite rates similar to electromagnetic force. However, gravitons is the only exchange particle not detected yet. These are all the sub branches or sub particles of the fundamental particles that I've explained in the very beginning of the lesson. Okay.
Okay.
Let me write few easy points for you for the strong force, for the weak force, and the electromagnetic force. Okay. When it comes to electromagnetic force, it's a long range force. Long range infinite. Okay, as given by the table as well. It causes all the chemical reactions. And वैसे तो हमने पढ़ ही लिया है कि it is the combination of electric and magnetic force. Electric force is the force हमने जो अभी ऊपर पढ़ा, and magnetic force भी हमने ऊपर पढ़ा. It's the combination of these two forces. So all the chemical reactions are due to these electromagnetic forces. Because atoms are involved, atoms has electrons and protons, they are repulsive and attractive forces. So all the chemical reactions are due to these electromagnetic forces. बाकी जो weak nuclear force था वो short range होती है and basically could be witnessed by the radioactive decay as given in the theory as well. ठीक हो गया and normally within the range of the nucleus ही होती है. Strong nuclear force जो होती है हमारे पास ये repulsive force होती है हमारे पास. Also keep this in mind. This is normally a repulsive force. And rest we already have discussed. Normally this weak nuclear force is masked by strong and electromagnetic force. So normally it is dominated by these two forces. So इतना ज़्यादा पेड़ ये नहीं होती है हमारे. And the gravitation force is a long range force and we have discussed everything. और जो हम उसकी बात कर रहे थे ना फंडामेंटल पार्टिकल्स ऑफ नेचर, उसके अंदर मैंने आपको बताया था कि लेट्स सी कि बेसिकली वी आर फेमिलियर विद मॉलिक्यूल्स. मॉलिक्यूल्स को हम लोग ब्रेक करेंगे तो हमारे पास क्या आएगा? एटम्स. एटम्स को ब्रेक करेंगे तो हमारे पास क्या आएगा? एटम्स को फर्दर डिवाइड करेंगे तो न्यूक्लियस आता है. न्यूक्लियस फर्दर डिवाइडेड इनटू न्यूट्रॉन्स एंड प्रोटॉन्स. And neutrons and protons are made up of quarks. So this is the basic building block of metal. क्वार्ट्स में हमारे पास जो है मतलब जो इलेक्ट्रॉन्स वो बहुत ज्यादा ये बहुत डिटेल्ड टॉपिक्स. आई डोंट नो व्हाई दे आर गिविंग एट दिस स्टेज, बट क्वार्ट्स से फिर हमने वो 6 जो है वो भी पढ़ी नहीं है. क्या कहते हैं एक्सिस्टेंस बोलेंगे. आई एम नॉट हैविंग द राइट वर्ड फॉर इट, बट there are 6 quarks जो up down top up down top bottom strange and charm ये flavors हैं quarks के ना. और इन्हीं से मिलके प्रोटॉन न्यूट्रॉन्स एंड इलेक्ट्रॉन्स एंड और भी बहुत सारी चीजें बनेंगी. I think so that's it for today. We'll resume from here tomorrow and do read it up till here. Okay.
Okay.
Allah.
Hello.
So there are 2 ways through which we could show the force diagrams, as well I have shown you in the previous lesson, that in which direction the weight is acting. These are the system diagrams, and if we put boxes or we take help from different shapes and draw the diagrams, they are known as the force diagrams. Free body diagram. So there are 2 ways in which force diagrams are shown. One is system diagram and the other is free body diagram. It normally have certain shapes through which would show the direction of forces, and in system diagram we actually take help from the object to show that forces are acting on it. Okay. As you could see here as well, a system diagram is the visual expression of all objects required, whereas a free body diagram is a schematic representation in which only the object being analyzed is drawn, with arrows showing all the forces acting on the object. That's not something that we need to memorize. It's just how you could show the force diagrams, how you could show that what number of forces are acting on a particular object, so forth and so on. Okay. Then there is a term known as net force or resultant force. Resultant force or net force is the sum of the number of forces acting on the object. And in order to find out the resultant force, we need to say whether the two forces are acting in the same direction or in the opposite direction. So if you could see in the following diagram, both the forces that are acting in the same direction, so they will get added. These forces are acting in opposite direction, it would be cancel out each other. These forces are acting in the same direction, and these forces are acting in the equal opposite direction. So again, we will subtract it from each other. So when the forces are acting in the same direction, we add the two forces. And if the forces are acting in the opposite direction, we subtract the two. So always put the bigger force first and the smaller force after it, especially when we are subtracting. Okay. Did you get this point?
Yes.
Yes.
Bigger force. बाकी इस थ्योरी के अंदर ये सब कुछ लिखा हुआ है, उन्होंने वो आप खुद ही रीड कर लेना इसके अंदर. So resultant force is the sum of the forces of all the forces acting on the object. Yes, we need to memorize the definition of it. वेक्टर डायग्राम से हमने उसको ऑलरेडी पढ़ लिया हुआ था. ये लिखा हुआ है. Different forces can affect on an object. The net force is the total effect of all these forces calculated by adding up all the forces acting on the object. So in this case, we could see that these forces are acting in the opposite direction. These forces are acting in the opposite direction. These forces are acting in the opposite direction. Acha, keep this one thing in mind, that zero resultant force does not mean that no force is acting on it. It only means that the number of forces that are acting on that object are cancelling out each other. And whenever the resultant force is zero, this means either the object is at rest or the object is moving with constant speed. Just say, in this particular example, this book is sitting on the table. The weight is acting in the downward direction and contact force is acting in the opposite direction. So the resultant force is zero. The object is at rest. In this force, the drag force and the weight of the object are acting in the opposite direction. They would cancel out each other and the object would fall with the constant speed. We are going to study this constant speed. This constant speed, when the resistive force and the weight of object becomes equal to each other while the object is falling, is known as terminal velocity. It is the maximum speed with which the object falls when the air resistance becomes equals to the weight of the object falling. And if the object is moving with constant speed, what would be the value of acceleration?
It will be 0.
Sorry?
It would be 0.
Yes, because constant speed has, when the object is moving constant speed, the acceleration would be 0. Here they have shown the forces that is acting in the opposite direction, so it would be subtracted. And here, net force. And also, the resultant force is always drawn where the bigger force is acting. Okay, so see, in which direction the bigger force is acting? In this direction. So the resultant force is drawn in this direction. Here the bigger force is acting in this direction, so the resultant force is drawn in this direction. And if the forces are cancelling out each other, we have not drawn any. This scale is basically telling us the direction of force. And you guys know that this length is basically the magnitude. Length shows the magnitude of the force. Am I clear up till now?
Yes.
Yeah.
motion. Newton gave this law to understand how motion is affected by certain things around us. So the Newton's first law is defined as the law of inertia. Let me see. Okay, let me write it down. Law of inertia. If you guys remember when आपको थोड़ा सा overview दिया था inertia का, inertia is a property of the body that is dependent on mass. So Newton's first law of motion is also called law of inertia. What is Newton's first law of motion? The
Law of
object
inertia.
will
Okay.
continue its state of rest or uniform motion unless an external force is applied on. That is, if the object is at rest, it would be in rest. If the object is moving with constant speed, uniform speed, it would keep on going unless an external force is acted upon it and tries to change the state of motion or the state of the body. And why it's called law of inertia? Because inertia is defined as the property of a body, the property of a body due to which it resists any change in its state of rest or uniform motion. See, the definitions are approximately alike. So inertia depends on mass. How to understand this property? For example, if we are sitting in a car and we are going on a straight road and suddenly a brake is applied, how our body would react to the brake? It's a very simple question. If we are sitting in a car going on a straight road and suddenly the brake is applied, what would happen to you?
You would move
Would
forward.
we would be pushed forward. Why do we get pushed forward? Because our body thinks that we are going in a straight line forward. So suddenly when the brake is applied, our body tend to stay in that state of motion. That's why we're pushed forward in the forward direction because our body would try to stop that change. That is why we wear seat belts while sitting in the car. That if suddenly the brakes are applied, our body would be pushed forward. In order to avoid any injury, we wear seat belts. So that's inertia. It tends to change the state of the keep the state of the body, which is at that particular time. So if we're at rest, we will be at rest. And if we're moving, the inertia would tend to keep that state and would not would try to change not to change the state of the body. So bigger the mass of the body, bigger it would be more difficult it would for us to change that state. Obviously, if the body is at rest and has a bigger mass, it would be difficult for us to move that body as compared to the lighter object. So inertia is a property due to which it resists any change. Focus on the word resist any change in its state of rest or motion. If at rest, it will try to keep at rest. If it's in uniform motion, it would try to keep in that state unless an external force is applied on it. Are we clear about Newton's first law and why it's called law of inertia?
Yeah.
Why the color is so dark? Even this is dark. Anyhow, let's see what's written in the book. Is my screen shared to you guys?
Yes.
Okay, that's fine. First law of motion deals with bodies which are either at rest or moving with uniform speed in a straight line. According to Newton's first law, a body at rest remains at rest provided no external force acts on it. No net force means the resultant force of all the bodies. Net force definition बताइए. What is meant by net force? It is the resultant of all the forces acting on the object. And here's the definition of Newton's first law. A body continues its state of rest or uniform motion provided no net force acts on it. So the only way through which we can change the state of the body is by applying some external force onto it. Let's read the same definition from the other book. They have not given me proper definition, but this is the point which I was explaining to you. Why it is more difficult to push a large man on swing compared to a small object? Why it would be difficult? Due to inertia. Okay? See, there's a difference in the resistance to a change in motion between the man and the child. Also, when you try to stop their motion, you would again notice a difference in the resistance to change the motion because larger man has more inertia due to more mass. And here is a bit of a definition. First law of motion specifies that there's a natural tendency of an object to remain in a state of rest or in motion in a straight line as inertia. And then they have asked, does all objects have equal tendency to resist the? Balki, answer me. Does all object have equal tendency to resist its state of rest or uniform motion?
No,
And why is that?
because every object has different mass.
Yes, because every object has different mass. Similarly, they have given this formula. An object at rest will remain at rest until an external force is applied. This foot is the external force on it. And if it's in motion, we need to stop. If we need to change that state, again, we need to apply a force on it. There are resistive forces present which would eventually stop the motion of the object. But if we want to stop the object before it actually stops, due to resistance, we need to apply an external force on. And if the resultant force is zero, change in velocity would be zero and acceleration would be zero. See, it means that in the absence of external force and an object at rest, it will remain at rest, while an object in motion will continue to move with constant velocity. No change in velocity or acceleration. उन्होंने basically यहाँ बताया. Rest of the theory is exactly the same that I've explained you in the first part, or you could read it on your own in the. There are certain examples given in the one. This is the inertia that I was talking to you about. Whenever the resultant force is acting, whenever you're moving on a curved path, now, the resultant force would always be towards the center of that curved path. Okay? Wherever you are, it would always act on the center of that curved path. And if you're moving on a straight line, the resultant force obviously would be zero. But if we're moving on a circular path or curved path, the resultant force would be towards the center. They might have written this as well here. ये example तो आपने coin की तो पढ़ी हुई है ना? Place a card on top of a glass and put a coin above this. If you quickly flick the card horizontally, the inertia of the coin will keep it at rest horizontally. The vertical force of gravity will pull it मतलब जब हम इसको सडनली पुल करते हैं ना, अगर हम इसको स्लो मोशन कैमरा से देखें, we would see that the coin would stay at that position for nanosecond, and it is due to inertia, but it eventually falls down due to the force of gravity. Because if there is some resultant force acting on the object, there would be some change in the state of the object. Then we have this curved. As a bus starts moving with uniform speed, if we hold up onto the pole, it supplies the force needed to give us the same motion as the bus, as we no longer feel pushed. But when the bus goes around a curved path, again we feel a tendency to move to the sides because now the resultant force is acting on us. The bus has changed its straight line motion, but we tend to move in a straight ahead. The same principle is again at the bow, but start to slow down or stops. So वो basically वही सारे meanings explain कर रहा है. Resultant force would only act if there is some change in the state of the body, and that is due to the changes in Newton's third law is very easy. Newton's third law is explained as the मैं यहीं पे लिख देता हूँ, action and reaction are equal in magnitude but opposite in direction. But this is only true if the masses of the two body. हाँ, इसमें एक और पॉइंट आपने माइंड में रखना होता है कि action and reaction always act on two different bodies. Action and reaction never acts on the same body. There must be two bodies on which the action and reaction would act. Since the magnitude of the forces are equal and only the direction is opposite, if the mass of true object is given, so we use this equation to show Newton's third law. What is the significance of negative sign in physics? We have discussed this in the previous lessons. What is the significance of negative sign? What it tells? What does it tell us?
It can tell direction.
It tells us that negative sign direction is opposite in vector quantities. For example, if we have something like that now, 12 equals to minus 12 meter per second. So the magnitude is same, only the direction is opposite. So whenever we see a negative sign, it means the vector has changed its direction. Changes in direction or decrease is shown with the negative sign. Normally, when it comes to vector, the negative sign indicates the change of direction. Here, action and reaction cannot cancel each other because they act on two different bodies. Action on one body and reaction on another body. So, football, when we kick the football, that is the action, and reaction force is exerted on the foot. So they both are equal in magnitude, but they are in different direction. So that's why they do not cancel out each other. Similarly, example of a rocket, the gases, propulsion is in the downward direction, the motion is in the upward direction. So for example, बल्कि theory, हाँ ये लिखा हुआ है. The exhaust from the rocket creates a downward force which creates an equal and opposite thrust in the upward direction. वो ऊपर हमने उसकी example की भी थी rockets की. Limitations of Newton's third law. This is something that we need to keep in your mind. Newton's law do not. अच्छा, ये points आपके parameters जरूर याद होने चाहिए. Newton's law are not readily applied on very small objects. As one goes extremely low, Newton's laws are not applicable. That is atomic level की वजह से हमने कल basic forces of nature पढ़ी थी ना, electric force, magnetic force, electromagnetic force, gravitational force, weak nuclear force and strong nuclear force. So इनमें से weak nuclear force and strong nuclear force atomic level के ऊपर आती थी. So when it comes to Newton's law, these are only applicable to everyday objects, not at atomic level. Similarly, Newton's law are not applied at objects moving at very high speed relatively with the speed of light. If something is approaching the speed of light, we cannot apply Newton's law on it. Relativistic mechanics basically deals with objects which are moving with the speed of light. This is very important. However, Newton's law are not exact but provide a good approximation on the larger scale and over the vast range of the particles. Are we clear about Newton's first and third law?
Yes.
Yes.
Okay, give it a read now. So the Newton's second law is when a force is applied on an object, an acceleration is produced, and that acceleration is directly proportional to the applied force and inversely proportional to the mass of that object. Let me share the whole screen and take you to the section. So Newton's second law is when a force is applied, acceleration is produced, which is directly proportional to the mass. Oh, sorry, directly proportional to the applied force. And inversely proportional to the mass of the object. Are you guys familiar with the meaning of directly proportional and inversely proportional?
A bit.
Okay. Tell me. What is the meaning of this?
Inversely proportional means when one thing is more, the other thing is less. And directly
Yes,
proportional
yes,
means
exactly.
when
If one
both are
increases, the other
the
increases. Yes, if one increases, the other increases.
yeah.
If one decreases and the other increases, that means inversely proportional. So acceleration is directly proportional to the applied force, and acceleration is inversely proportional to the mass of the object. So when we combine these two equations, we get F over M. And when we remove the sign of proportionality, we get a constant. And constant would be 1 if a force of 1 Newton is applied to an object of mass 1 kilogram, producing an acceleration of 1 meters per second square. So from here, we have F equals to ma. Here m is the mass of the object, a is the acceleration, and F is the applied force. Force has a unit of newtons. And what would be the unit of, Madam Newton would be equals to what value? What is the mass of, what is the unit for mass? What is the unit of mass? Hamna.
kg.
And what is the unit of acceleration?
Kg meters per second square.
Acceleration only.
Oh, meters per second square.
So 1 Newton is equals to 1 kilogram meters per second square. This is the SI unit of force. Clear?
Yes.
Yeah.
Our next and last topic of today is mass and weight. Weight is a type of force. We have studied that in the beginning of the lesson. And mass is measured in kilograms. Which one is a scalar quantity and which one is a vector quantity?
Mass is a scalar quantity and weight is a vector quantity.
Why I cannot choose any other marker? Hold on. Okay. So mass is a scalar quantity and weight is a vector quantity. Mass is defined as the amount of matter in a substance, and weight is defined as the force with which the earth attracts the body towards its center. ठीक है? Mass remain same everywhere, whereas weight varies as the value of G changes. G is gravitational acceleration. And for Earth, its value is 9.8 meters per second square or 10 meters per second square. So as the value of G changes, as we move to some other planet or we move to, we have a difference of height or position. If that changes the value of G, the weight would change accordingly. So the formula of weight is given as, what is the formula of weight? Weight is given as mg, and m is the mass and g is the gravity and weight. Then normally there is another point that come in the discussion is that for weight, to measure mass, we use physical balance or electronic balance. And weight is measured using spring balance. I will show the diagrams of them as well, so do not worry about that. Am I clear up till here? The difference between the mass and the weight and the respective definitions are Newton's second law.
Sir, can you explain the Newton's second law again?
Newton's second law is defined as whenever you apply force on an object, for example, this is an object, I apply force on it. Due to this force, this object will have an acceleration. This acceleration upon the application of force, let me redraw the diagram. This is the object, okay? I have applied some force onto it. Due to the application of this force, we have studied that it could change the motion and could change the speed or position. Okay? So due to this applied force, some acceleration would be produced into that object because change of velocity with respect to time will occur. Okay? So I have applied force onto that object, and due to this force, acceleration is produced. Yahan tak clear hai? Now,
Yeah.
this acceleration which is produced is directly proportional to the applied force and inversely proportional to the mass of the object. Which means if I'll increase the force, acceleration would increase. And if I would increase the mass, acceleration would decrease. That's Newton's second law. When a force is applied onto an object, acceleration is produced. That acceleration is directly proportional to the force and inversely proportional to the mass of the object. That's Newton's second law. And it's given as F equals to ma.
Okay, now I got it.
Anything else?
No.
Shrino?
No.
Okay. Let's see what weight and everything is, Okay. Again, the definition. Mass is the amount of matter an object contains, and it is a measure of its inertia. Whereas weight is defined as the gravitational force acting on an object. And weight is given as mass into acceleration due to gravity, which is equals to mg. Weight is a vector quantity and g is also a vector quantity. That is why they have an arrowhead on it. We have studied that about how to show vectors. We know either we write the bold letters or draw an arrow on it. Then they have given us the equation that F equals to ma, where F is replaced by W and A is replaced by G when an object is falling freely. Okay? We can change this equation F equals to ma to W is equals to mg when an object is falling freely. Why is that? Because we know that the only force that is acting on the object is the force of gravity. So A is replaced by G when an object is falling freely. So when A is replaced by G, we could say that force is equals to weight. Did you guys understand this part?
Yeah.
Yeah.
Okay. Then on the scales discussed scheme, this is the spring balance. Using the spring balance, we'll get the weight. And if we want to find out the mass of the object, what will I do? I'll divide weight with the value of G. I'll get the mass. Force sensor, and there are so many other devices which would help us to find out the mass of the object. Spring scale is, उन्होंने यहाँ mentioned भी किया, it is force acting on an object. It consists of a spring which gets when a force is applied to it. Stretching of the string is a measure. Moving on the जो आपको you could see here. The diagram is really blur, but when you hang something onto the object now, the spring gets stretched and there's this pointer which is moved on the scale. From that value, we get the force value. Okay. Now, the force sensor uses an electronic gauge. अब वो इस apparatus के बारे में बात कर रहा है. This force sensor uses an electronic gauge to measure force with a higher degree of accuracy. It gives a digital reading on the graph of the force when the interface with the computer. Weight is the effect that gravitational force on an weight is the effect that gravitational force has on an object. Mass is the amount of matter in an object irrespective of the gravitational force. So मैंने आपको differences बताए थे ना कि mass would remain same everywhere. It would not be changed if its position is changed, if or if the value of g is changed. It would remain same everywhere. For example, our mass would not change either we are on moon or on Mercury or any other planet, but our weight would vary with respect to our positions because value of G changes with respect to the positions. Okay. Then the gravitational field, it is measured as F is equals to mg. The region around a non-contact force where a magnetic force is operative is known as a force field, where the region around a massive object where the gravitation force is operative is known as gravitational field. जैसे magnet के around एक field exists. Field force हम basically general define करते हैं. It's an area or space around an object in which it could apply force on other like bodies. ठीक है? फोर्स फील्ड की अगर हम जनरल डेफिनेशन की बात करें तो force field is defined as force field is an area or space around a charge in which charge नहीं object. अगर इलेक्ट्रिक फील्ड हो गया तो यहाँ पे चार्ज का टर्म लिख देंगे around an object in which it can apply force on other object. फॉर एग्जाम्पल जैसे लाइट बल्ब की एक रेंज होती है ना, उसकी लाइट फॉर एग्जाम्पल यहाँ तक रीच आउट कर सकती है. सो दिस एरिया would be known as force field. Similarly, you must have played with the magnets as well. We know that the magnet at a further distance do not attract each other, but there is a certain point at which if we place a magnet, they would immediately would be attached to each other. So there is a region around an object in which it can apply force on other objects are known as force field. So similarly, how do we define gravitational force? Gravitational force is operative, region around a massive object. कल मैं आपको बता रहा था ना कि gravitational force is only influenced if there is a major difference of mass between the two bodies. For example, if a person is standing next to a planet, there would be a major effect on it, and the gravity would be under. मतलब उसमें अच्छा खासा will feel the effect of gravity there. But to feel that gravitational force, there should be a major difference between the two masses, which are in contact with each other. Obviously, it's a non-contact force, but the mass should be very much the mass should have a greater difference between each other. अब उन्होंने gravitational field strength को explain किया हुआ है यहाँ पे. Gravitational field strength is the amount of force per unit mass, here you could see, acting on an object in the gravitational field. Gravitational field की definition उन्होंने अलग से explain की हुई. Gravitational force has a different definition. And again, gravitational force is attractive in nature. उसकी direction है, so it is a vector quantity, and always towards the center of an object. And on gravitational field strength का जो equation है उन्होंने बताया, basically हम लोगों ने उसको Newton's second law से derive किया. Since A and G are similar, so it would have the same unit of as well. Force का Newton and mass का kilogram, Newtons per kilogram or meters per second. And is a vector quantity that has a direction downward or towards the center of an object. यहाँ पे उन्होंने वही बात की जो मैंने आपको बताया कि A and G are approximately equal, so ये values interchangeably use कर सकते हैं. ये important point है. Gravitational force decreases as we move away from the surface of the earth. Therefore, gravitational field strength also decreases. Also, on different planets, we have different gravitational field strength as given in yes table दिया है. Mercury में it has a value of 3.7. Venus it has a value of 3.9, 9.8. 3.7, 24, 9, 8, 11, and 274. So where our weight would be greatest? On which planet our weight would be greatest? Shirino, on which planet our weight
Yes.
would be greatest?
Planet Jupiter. Yeah,
That shows you
Jupiter.
were not giving attention at all to
I
whatever I was
was.
saying. Then the table is right in front of you. Do you think that Jupiter has the greatest value of gravity?
Yeah.
Amna?
Yes. Sir, you're talking about planets, right?
Yes. Sun is
Yeah.
a
The
planet.
sun's not a planet.
Sun is a planet.
Sir,
My dear
it's a
child, Sun
star.
is a planet. Star basically,
Sir, it's a
you would, I know it's a star, you would get to understand the meaning of planets and stars, everything in the later stage. But in this particular table, they have written the name of Sun. So I would expect you to just uh, go through whatever they have given the data of. Because they have
okay.
mentioned
Then it's
Sun
a sun.
in the table, then it would be Sun. Okay?
Okay.
Planets and stars, they have a very deeper meaning that we do not need to get into. But since the table shows it's a planet, so let's just say as it's written in the book, we're not going to argue about it. Do we have any question up till here? So far we have discussed that momentum is the property of a body due to its motion. So as long as the object is moving, it will have momentum. If the object stops, its momentum will become zero. Momentum has a symbol of P and the formula is given as m into E. So if velocity is zero, that is object is at rest, so its momentum will also be zero. If the object is moving with some velocity, it will have some kind of momentum. And momentum is a vector quantity. The unit for momentum would come out to be mass is the unit of kilograms and speed is the unit of meters per second. It also has a unit of newtons into second, which I told you would be based on the next equation that we're going to. So the definition given by both of you is K Newton second law tell us that acceleration produced due to force is directly proportional to the force and inversely proportional to the mass of the object. But here we need another equation. What is the formula for acceleration that we have studied in the previous chapter?
Uh, Velocity divided by time,
Change of velocity or just velocity?
change in velocity.
So it would be Vf minus Vi over T. In certain books, it might be written as V minus U over T as well. So V is given as final velocity, used as final velocity, and U is symbolized for initial velocity. So don't get confused with that in either case. If we put the value of A into this equation, we would have an equation something like this. F is equals to mv minus mu over t. As we have studied previously, that mv is basically momentum. So this would show mv would show the final momentum and mu would show the initial momentum divided by time. For delta t, you could also write delta t as well because time difference भी होगा final initial velocity के in between. So we can write it as delta p over delta t. Am I clear up till now? Up till here, sorry.
Yes.
Yeah.
Okay. From here, we'll get an equation as delta P. I will rearrange this equation as equals to force into delta T. I rearranged this equation. ठीक हो गया? So from this, I could write a word equation as rate, sorry, not rate, change of momentum is equals to force into time. This force into time is known as impulse. What do we call it? F into T is called a quantity which is known as impulse. So we could write it as change of momentum is equals to impulse. Clear? Or we could write it as delta P is equals to I. Now let's discuss what impulse is. But before that, let me know if there's any question. Is there any part you want me to devise?
No.
Okay. Moving on to how do we define impulse or what impulse is. Impulse is basically a force that acts for a very short interval of time. For example, when during cricket, when ball hits the bat, so the movement, for example, this is bat and this is ball. The moment it hits the ball, so bat, at that moment, the force that would be produced would be known as impulse. For example, if we kick the football, if I'm kicking the football, so the moment at which my foot would be in contact with the ball, at that moment, the force that would be present would be known as impulse. A force that acts for a very short interval of time is known as impulse. Clear? Are we clear? Can I go to the next topic?
Yeah.
Okay. Now, so far, the equations that we have done is of momentum, which is P equals to mv. We have done F is equals to ma. We have done F is equals to mv minus nu over T. And we have done F cross T is equals to mv minus m. So this force that is equals to rate of change of momentum is known as average force. Average force is equals to rate of change of. Okay, this is change of momentum divided by time. So rate of change of momentum is known as average force. So if there comes a question where he asks you to find out the average force, so the formula that we're going to use is sometimes if the examiner has mentioned that the initial velocity is zero, then it simply means that F is equals to mv over t because u is zero at that point when initial velocity is zero or object is starting from rest. Both have the same meaning. So do not get confused in looking for the values that where is the value given? Is the second velocity is not given? That velocity is obviously zero if the examiner, or even if the examiner has said that the object comes to rest. If the object comes to rest, so con zero hoga, then v would be zero. So it's something that you need to understand yourself. Okay,
Yeah.
that is the end of our chapter, I guess. Let's go to book and see if there's anything else left to be discussed. The recoil motions. Okay, the last topic. I guess that is Newton's law and conservation of moment. Okay. Conservation means that the initial and final values are always equal. This is the example I was telling you. The moment the bat touches the क्या कहते हैं ball, the force at that particular of time would be known as impulse. It might have written in the theory as well. You guys could go and read it yourself. This is the formula of impulse is equal to change of momentum. And rest of the formulas might, this is the net force or the average force that I've explained to you just right now. This is the one we took help to reach to this equation. And simply the moment. Okay. There's this only one topic left in which we need to discuss the conservation of momentums and isolated system. Here is written an isolated system. Isolated system is defined as the system in which no external forces acting. Whatever the forces are, for example, if this is the box, we have certain objects into this system and it's a closed system so that no external forces acting on it. Such a system is known as isolated system. They have also written the definition here. For an isolated system, there is no net force acting. If therefore Newton's second law in terms of momentum can be written as, since F is 0, this would be equals to rate of change of momentum over time and time when it will be multiplied over here, t into 0 would be equals to 0. So we would be left with Pf minus Pi equals to 0 and Pf would be equals to Pi. This is normally the case when we talk about certain systems which are initially at rest or has no velocity and then has a certain velocity. For example, if we fire a gun, fire a bullet from a gun. So what would be the initial momentum of gun and bullet before firing?
0.
It would be 0 because both the gun and the bullet is at rest. After firing the bullet, so what would be the equation? 0 is equals to m capital V into m small v. Sorry, not into m. Minus. So capital M shows the mass of gun and V shows the velocity of gun. It's not like a gun would start moving. We obviously we know that when we fire a bullet out of it, we experience some kind of a recoil velocity. Back thrust आता है उसमें से हम लोग, ठीक है? So we're talking about that velocity, not like the gun would start moving along with the bullet. This is the mass of the bullet. I'm writing B for it, and this is the velocity of bullet. I do not have enough space of it. So mv would be equals to mv. So if we need to find out the velocity of anything, we would find it with the help of this. Okay. Since they have tried to find out the velocity of the gun, so Vg is equals to mvb, mb for mass of bullet, b for velocity of bullet, and m. Here the negative sign is being shown. कि उन्होंने final momentum. There's this term used as law of conservation of. Into that उन्होंने sum of momentum we'll check here, okay? Initial momentum was 0 for both and sum of both bullet and वो final momentum, which is the sum of momentum of bullet and gun. ठीक है? So plus sign उन्होंने ऐड किया हुआ, तो obviously अब इसको उस साइड पे लेके जाएंगे, it would have a negative sign with it, so we will have some equation. Same goes for rockets and everything. If we go through this example, we would have all the values given. Ahmed fires a bullet of 17 grams from his hunting gun for a mass of 3 kilograms. So mass of bullet, mass of gun is this, mass of bullet is 17 grams. If the velocity of bullet was 350 meter per second, what would be the recoil velocity? So we would straight jump into the equation that we have here. Mass of bullet is 17 grams. So into kilograms हम कैसे जाएंगे? 17 divided by 1000. So 0.017 into bullet velocity, which was 350 divided by mass of bullet. So the gun's velocity is 1.98. See, I told you कि recoil velocity होती है. Its value is very small. So in comparison to the velocity of bullet, which was 350, the gun velocity is only 1.98. And the negative sign is indicating what? मैंने last lesson में भी बताया था negative sign किस चीज को indicate कर रहा होता है? What is the significance of negative sign?
And the
हाँ,
opposite
it has an
direction.
opposite direction. It has an opposite direction. Good. So that is the end of chip number 3. Review the topic that we have just done and let me know if you have any questions from it.